Hey, welcome to The Explainer. You know, we live in this world that feels, well, digital. Almost like magic, right? But behind every single search you do, every show you stream, every little AI creation, there's this enormous, physical, and mostly hidden world of machinery. So today, we're gonna go inside.
Yeah, just think about it for a second. You ask an AI to write a poem for you, and boom, the answer shows up in seconds. But where does that actually come from? It feels like it just materializes out of the cloud, right? Out of thin air. But it doesn't, not at all. That answer was born inside a building, a very specific and very powerful kind of building.
So these buildings, the ones that are quietly powering our entire digital lives, they're basically the invisible factories of the 21st century. I mean, they don't have smokestacks, but believe me, they are consuming a staggering amount of power. They are the real engines of our modern economy, and they're called data centers. Okay, so what is a data center really? At its most basic level, it's the physical home of the internet. It's a purpose-built facility just jam-packed with computers. We're talking servers, storage drives, networking gear, all of it just humming along 24/7. Seriously, without these places, the digital world as we know it, it just wouldn't exist. Simple as that.
And you know, this whole idea isn't exactly new. It's just evolved at this absolutely blistering pace. We went from these things called machine rooms back in the 60s, which, held maybe a single mainframe computer, to the server farms of the dot-com boom. Then, in 2006, Amazon Web Services launched, and that really kicked off the whole cloud era. And today? Well, today we're in the hyperscale era, with single campuses the size of dozens and dozens of football fields. It's just massive. So what is the single biggest obsession inside these incredible buildings? It's not just about being fast. It's about something way, way more important. Never, ever, ever turning off. And this slide really shows you how they measure that reliability. And the difference is just staggering. There's this group called the Uptime Institute, and they have a rating system from Tier 1 to Tier 4. Now, a basic Tier 1 facility, it might be down for over a whole day each year. But a Tier 4 facility, and this is the kind that major cloud providers use, that is engineered to be down for less than half an hour per year. And to do that, you have to duplicate every single component. I mean, everything, from the power lines coming in to the cooling pumps. So for decades, the industry got really, really good at this model of building bigger, more reliable, and more efficient data centers. And then a revolution happened, one that just changed all the rules. And that revolution was, of course, the rise of generative AI. Suddenly, there was this completely new kind of demand. The task of training an AI model, it's a brutal, power-hungry marathon. It makes traditional computing look like a leisurely stroll in the park. All of a sudden, the old way of designing these factories, it just wasn't going to cut it anymore. And this is where we see the absolute core of the problem. Something called power density. So a traditional server cabinet, they call it a rack, might draw, say, 10 kilowatts of power. Okay, but a rack that's packed with those high-end GPUs you need for AI, that can draw 100 kilowatts or even more. That is a tenfold increase in power and heat in the exact same amount of physical space.
And get this, 100 kilowatts? That's just where we're starting. Engineers are already planning for next-generation systems that could cram over 600 kilowatts into a single rack. The engineering challenge to cool that? It's just mind-boggling.
So this intense concentration of power, it's not just a problem for the engineers inside the data center. Oh no. It's creating a massive, massive problem for the world outside of it, for all of us. And here's a really crucial point. For every watt of power that goes to the actual computer chips, you need almost another watt just for the support systems. And as you can see on this chart, the vast majority of that overhead, we're talking around 70%, goes to one single task: cooling. Just getting rid of all that incredible heat. So when you add up all these new AI factories, the numbers just become, well, they become hard to wrap your head around. Global electricity demand from data centers is on track to double by 2030. Just let that sink in for a moment. An entire global industry, doubling its energy footprint in just a handful of years. And to make that feel really real, just look at a country like Ireland, which is a major tech hub in Europe. By 2026, it's estimated that data centers could be consuming nearly a third of the entire country's electricity supply. This isn't some far-off future problem. Electrical grids are feeling the strain right now. So the whole industry finds itself in this massive race. Our digital ambition is just outstripping our physical infrastructure. So engineers are having to radically rethink how these AI factories are built, how they're cooled, and most importantly, how they're powered. The first and most urgent change is about cooling. For those super dense AI racks we were just talking about, air, well, it just can't remove the heat fast enough. It's like trying to put out a bonfire with a squirt gun. The solution? Liquid. Water and other fluids are literally thousands of times more effective at absorbing heat than air is, which makes liquid cooling an absolute necessity for AI hardware. And there are really two main ways they're doing this. The first is called direct-to-chip, where you basically bolt a tiny liquid-filled radiator right onto the hottest components like the GPUs. The second, which is even more extreme, is called immersion cooling, and it's exactly what it sounds like. You literally submerge the entire server in a specialized non-conductive fluid. It sounds totally wild, I know, but it is incredibly efficient. But, better cooling doesn't solve the core problem. Where does all that electricity even come from? With public grids already strained, companies are now exploring everything. I'm talking dedicated solar and wind farms, on-site natural gas turbines. They're even seriously considering what you might call the nuclear option, planning to power these massive data centers with new, small, modular reactors. And all of this brings us to this really fundamental tension, right at the heart of our modern world. It's this conflict between our seemingly limitless appetite for data and the very real, very physical limits of our planet's resources. This statement right here really captures the central challenge perfectly. The data center sector is projected to double in size in just 5 years, but this digital ambition is just outstripping our physical world infrastructure. We're building this incredible digital world that relies on an unprecedented expansion of physical stuff, power plants, transmission lines, water, at the exact moment when all of those resources are already under immense pressure.
So, the next time you ask an AI for a poem or a picture or an answer to a question, just remember that invisible factory that made it all possible. And ask yourself this really critical question. As AI continues to build our future, how exactly are we going to power it?